Anjuman, you can
Well,
start.
okay, thank you. So, good evening, good morning, or good afternoon, everyone, depending on which time zone you are in. This is Anjuman Antil, and I welcome you all to this Inspiration Series lecture organized by the Center of Research in Emerging Economies of Jindal Global School, Jindal University. Today, I have the pleasure of introducing two distinguished speakers, Dr. Atanu Lahiri and Dr. Debabrata Dey. Professor Dr. Lahiri is an associate professor of information system at Jindal School of Management, University of Texas at Dallas. He received his PhD from Simon School of Business, University of Rochester. His research interests span a number of domains, including digital piracy, computer security, healthcare, and telecommunication services. His papers have appeared in acclaimed journals like Information System Research, Informs on Computing, Journal of Management Information System, MIS Quarterly, and Sloan Management Review, among others. He has also served as an associate editor for Journal of Management Information System. Dr. Debabrata Dey is currently the Marion B. and the Ingersoll Professor of Information Systems at Foster School of Business, University of Washington. He received his PhD from Simon School of Business, University of Rochester. He received his PhD from his current research interests are in the area of economics of information systems, with primary focus on information security and digital piracy. His papers have appeared in journals like Management Science, Operational Research, MIS Quarterly, ACM Transaction on Database Systems, and Sloan Management Review, several other acclaimed journals. He has served as a senior editor and associate editor of Information System Research and as an associate editor of Management Science. The topic of today's talk is versioning, a tool for information dissemination. Before we invite Dr. Lahiri and Dr. Dey to commence their talk, I would request you to please note that during the talk, you can ask the question in the Q&A box or the chat box. The speakers will most likely take up the questions in between and at the end of the session. So, Dr. Lahiri and Dr. Dey, thank you so much for accepting our invite, and we are now eager to hear you.
Okay, I'm Atanu. I'll get started with the talk, and then towards the end, I will ask Dave to join and finish the talk. So first of all, thanks a lot for inviting me. And I was just telling everybody that I have some connections with Chitrakalpa because his dad used to be one of my teachers. And also, it seems that we both work in some Jindal school. So that's also a nice connection to have. And I'm really delighted to have this opportunity to talk to all of you. So our talk is about versioning, a tool for information dissemination. And this is actually a work in the area of economics of information systems. There's a large group of people who work in this particular area where they use economics-based tools, game theory-based tools to study issues relating to information goods in particular. So information goods means goods such as software, movies, songs, anything that can be digitized, those types of products. So that's basically the broad area. So let's start getting used to our specific topic. So can I move the slide? Okay. So information good, one of the main characteristics is that it's an experience good. So which means unless you experience it, you do not know how good it is. So for example, a movie, unless you watch the movie, you do not know how good it is. You may have some priors. For example, Amitabh Bachchan is in the movie, so you expect it to be of certain quality. But at the same time, unless you see the actual story, actual direction, actual music or whatever is in the movie, you do not know, you are not fully sure about its quality. So you have to experience it. In other words, these goods invariably have an experience part. So this word experience part we borrow from prior literature. Now, one of the important things of any, well, let me just take a step back and give you a brief background of different types of goods. There can be also search goods. Search good means goods that whose quality you can see even before you experience. For example, the quality of a light bulb. If you know it's a 60-watt bulb, then you know how much light it is going to give. Okay, so there's not much to think about after that point. But for information goods, that's not the case. You have to experience it to know it. Now, there's a fundamental difference between information goods and experience goods. That is how information impacts their consumers. So information goods, because they're experience goods, when you give consumers, they become more heterogeneous. So let me explain this. For example, think about something that we can all relate to, which is the detergents that we use for cleaning our clothes. So if I ask you about the aroma of a detergent, how your clothes actually smells after you clean it with the detergent. Now, this is more subjective. So initially you may have a prior, you may say, okay, I expect the smell to be good or whatever, but after actually trying the detergent, some people will say, wow, I really like the aroma. Some people will say, this is an awkward lemon smell. I really don't like this awkward lemon smell on my clothes. So this is subjective. So initially you are all thinking the same thing, but after you try the detergent, you are going to diverge in terms of how you actually value the product or how much you like the product. This is different from the search part of the good. So think about how well the detergent cleans a stain. Now, initially, we may have some priors about it, and some people may think it actually cleans it. Some people may think it doesn't, cleans, tough stains. But after you try the detergent on some dirty clothes, you can see whether it cleans or not. And everybody will converge to suppose it's a good detergent. In that case, everybody will converge to this assessment that the detergent actually cleans the stain. So there is no doubt about what happens after you try it. So for search goods, after you try, you converge in terms of its worth. But when you're talking about experience goods, when you give consumers information, you diverge, because some people may like a movie where there's a lot of fighting, but some people may say there's too much fighting. Okay, so we are talking about information goods, which means when we give consumers information, they start diverging in terms of how much they like the product. So this is basically the background of the paper. Now, what is the implication for this experience part on the pricing of an information good? So a lot of literature actually exists in our discipline. So people have said, okay, if people need to use these goods to know their true valuation, then you should perhaps offer trials, or you can offer a freemium kind of strategy where they can use some part of the good for free, but then for the remainder of the product, they have to pay a premium to use the rest of the product. So that is the freemium strategy. And also some people have argued that you can use a version to upgrade strategy, which means you offer a base version, a lower version of the product at a lower price, which many people will buy. And after using that base version, whoever likes the product, think about a video game. If you like the video game, then you are going to buy more add-ons, more avatars, more weapons, or whatever for that video game. And you are basically going to pay for the premium features. So this is called the version to upgrade strategies. So all these strategies, basically what they are saying, they are basically saying that we can use some sort of versioning. So basically there is a base version that you want to sell, and upon experiencing the base version, the consumers learn about its true worth, and then you want to sell them the full version, right? The full product or the premium features. So that's basically at the heart of this argument. This is some kind of vertical, differentiation in economics literature. Now, in this particular context, the vertical differentiation is actually motivated by the idea of information dissemination. You want to inform consumers about the value of the product. Now, the question is, can such a strategy be optimal? So why we are asking this, even though there is a large amount of literature, that show that such a strategy is optimal. So this question is actually very important. Let me explain why we are asking this question once again in this paper. First of all, one key feature of information goods is that all versions of an information good has the same marginal cost, which is zero. It doesn't, take you any money to reproduce a software. You just make a copy of it, and that's about it. It's not like a car that if you have to make another car for another user, then you will have to incur extra cost. You can serve additional users at no additional cost. Now, normally in economics, if if you want to use vertical differentiation, one essential condition, one necessary condition for vertical differentiation or versioning to be profitable is that the marginal costs should vary between the versions. So should vary across the versions. So for example, if you have a very basic car and think about a very premium high-end car with a lot of fancy features, a lot of safety features, a lot of high performance engine and so on, the basic car is cheaper to make and the premium car is more expensive to make. And because there is a cost difference, such a strategy actually works. That's why you see a lot of basic cars in the market and a lot of premium cars in the market. But if it was, if it were just as costly to make a premium car as it were to make a basic car, then you would not have vertical differentiation, because for the same money, if you can make a better car, you will just make the better car. You will never make the stripped down base version of the car. If it costs you the same money, why not make the better car? And economically, therefore, if you think about it, economically, versioning is not justified for information goods. This is before accounting for the experience angle. This is before accounting for the experience angle. Because information goods, whether you are making a copy of the Windows Enterprise or Windows Home Premium, there is really no difference. It's still zero. Making a copy of a software still costs you zero. So the question is, then we should just be making the premium version of the software or premium version of the product, and we should not be spending time on making the base version of the product. This is even before you account for the experience part. So versioning itself is not very appealing for information goods. That's actually the point number one. Now the question is, can information dissemination then make versioning optimal? Well, that is also, unfortunately, as it turns out, if you look at economics literature, that also is not the case. Information dissemination does not make versioning any more appealing. Let me explain why. So the idea is this: as I mentioned, that if you give consumers information, let me give you the high level idea and then let me explain the example on the slide. So if you give consumers information, they become more heterogeneous. When they become more heterogeneous, that sort of increases the demand elasticity. And when demand elasticity increases, from your basic economics, it becomes very difficult for the manufacturer to charge one price and extract all the willingness to pay from the consumers. It becomes very difficult. So in other words, giving consumers information actually backfires. And this idea has been discussed in many papers, including the seminal work by Johnson and Myatt in American Economic Review, which is actually one of the papers we take as our motivation, the paper to pivot our paper. We pivoted our paper on this particular paper, Johnson and Myatt in 2006, American Economic Review paper. The idea is very simple. Let me explain the idea of the Johnson and Myatt paper and let me rephrase it in our terms. So think about two uninformed consumers. Suppose let's consider the case of two uninformed consumers, the example on the slide. And initially, they just have a guess that the product is worth $6 on average. But if they become informed, then one person would know that the product is actually really good and they diverge. So basically, if you inform them, they diverge. One person starts liking the product and that person is willing to pay up to $10, while the other person is willing to pay only $2. But if they don't know, they both want to pay, each of them will want to pay $6 on average, $6. So on average, there is no change. On average, the willingness to pay is still $6 before and $6 after. The difference is that initially they are at $6, but after experiencing the product or after learning about it through some other means, they value the product differently at $10 and $2 respectively. Now, in this case, if you do not give them information and charge a price of $6, then they will both buy the product because they are willing to pay up to $6 for the product. So the total revenue in this case will be 6 plus 6, $12, right? However, if you give them information, now they become more heterogeneous. One person is willing to pay 10, other person is willing to pay 2. In this case, you have basically two choices. You can either charge a price of 10. If you charge a price of 10, only one consumer will buy it. The person who values it at 2 will not buy it. And your total revenue will be just $10. If you price it at 2, then both of them will buy it and your revenue will be $4. Now, regardless of whether you price it at $10 or whether you price it at $2, you are not making $12. You are making at most $10. So that's basically the main idea. Now, so the question is, or let me rephrase it in another way. So this is basically the main point of the paper. Think about this way: when they are uninformed, you are able to get $12 out of them by charging a price of $6. And this $12 is the same as $10 plus $2. Meaning when they are uninformed, by charging a price of $6, you are able to extract their entire willingness to pay for the product. In other words, keeping the consumers in dark is the same as first degree discrimination, or what some people, in the business, they call it personalized pricing. So if you were able to charge these two consumers their full valuation, then you would be charging $10 and $2, and you'll be making $12. But that you can make if they are uninformed anyway. So why bother them informing when without informing them, you can extract their entire willingness to pay? So in other words, versioning itself is suboptimal when you do not account for the experience part. And if you account for the experience part, there are no positives. That's what the Johnson and Meyer paper is saying. There are no positives if you inform them. So giving information is bad, versioning is bad, and the combination of the two should be bad. So that's basically the main idea. The question is, how does then all the papers I talked, how do all the papers that I talked about in the previous slide, how do they actually explain, the strategy of versioning to give information? I mean, how do they justify it? So they basically they make a very strong assumption. The assumption is that they assume that the average posterior willingness to pay is larger than the average prior willingness to pay. So they are basically saying, hey, initially the product is not worth $6 to them on average. The product is probably worth $3 to them average. So they are, so the most you can get when they are uninformed is 3 plus 3, $6. But if you give them information, then their valuations become 10 and 2. So you can charge a price of 10 and you can get $10, and 10 is more than $6. So that's basically their argument. Their argument is that the average valuation per consumer valuation has to increase for such a strategy to work. And that is basically the result we challenge in the paper. We said, does it really have to be the case that the average valuation increases? Because average valuation increases sounds like a very, very strong assumption to us. Basically, you are saying that consumers have inconsistent priors. Like as economists would say, they have inconsistent priors. Can you not explain all of this without, baking in inconsistency in your model? So that's basically the main point. So let's look at this. In a diagram, what I just said. So on the right-hand side, we are talking about just regular information goods, excluding the experience part. So that's basically the blue line on the right. And this is basically where all consumers know what the valuation of the good is. Well, I mean, their valuations for the good, all consumers know that. In this case, versioning is not optimal because, as I said, because the marginal cost is 0 for every version. There is no cost differential between the versions of the product. The cost is 0 for every version of the product. On the left, in red, we have what we call the curse of Bayesian consistent prior. That's basically in red. So we have the color coding on the slide. So on the red, in this case, nobody knows about the valuation. But if no one knows about the valuation, I just argued, keeping them in dark is the best strategy for you. That is same as the first degree discrimination. You cannot beat that with a second degree discrimination like versioning. You cannot beat that. So on the left, you have a situation where versioning is not optimal because of the curse of the Bayesian consistent prior. So meaning if you assume consistent prior, giving information is always suboptimal. So given that, now it is almost natural to conclude that there is no benefit to giving information when consumers have consistent priors, meaning the revision, the valuation revision that takes place as a result of their experience, when that does not change the average valuation, there is no point in giving them the information. Why it is natural to think? Because at both extremes, when no consumers have fit information, all consumers are in the dark, it's not optimal. you would not want to give information, and versioning is suboptimal. When all consumers have feed information on the right, because of the marginal cost, giving information is suboptimal. So you would say in the middle also, I can interpolate, and that's basically our natural instinct. Let us interpolate, and by interpolation we can say that versioning is also not suboptimal in the middle region as well. So, but the question is that really true? And that is basically what we try to understand in this paper. And even before going in the detail, the interesting result in this paper, as we will show, that actually the interpolation does not work. Just because a result is not true at both ends does not mean it's not true in the middle. And this is something all the prior papers in economics, marketing, information systems, you look at the literature, all of them miss these basic points. So they basically look at the two extremes and they try to infer about the things in the middle. But as we will show, that their analysis is extremely brittle. And if you allow some consumers, maybe a small fraction, 1% or 2% or 99%, doesn't matter. Even if you allow a fraction of consumers to have feed information and the other, the rest of them to not have feed information means their knowledge of the experience part, and the rest of the consumers don't have any knowledge of the experience part, then the prior literature completely falls apart. And versioning can be surprisingly optimal despite the two negative sides I talked about, the zero marginal cost and the fact that keeping them in dark is always the profitable strategy. Despite those two things, in the middle, surprising things can happen. And that's basically the main point of this paper. So let's describe our setting. So I want to tell you that this setting is a slight simplification of the setting in the main paper that we shared. The paper, we of course have a slightly more general model because you want to publish, so you want to impress people. So you have a slightly more general model. So here I will present a slightly simpler version of the model, which is easier to follow but gives you the same insights. So here we'll specifically assume that a greater fraction of consumers already know about the product, and this beta is a parameter. It can be 1% or 99% or 50%. It can be anything. And which means they already know about the product, so they don't care about their experience. They already know the movie is good or bad, or the software is good or bad. They already know about the product. But for the remaining 1 minus beta fraction, they initially have a prior. They don't know. They are like at the $6. But if you tell them, if you give them more information, they will start diverging. Some of them will move towards 10, and some of them will move towards 2. So that's for the remaining 1 minus beta fraction. And this setting is actually quite realistic also. It's not just for theoretical interest. It's quite realistic because people sometimes have familiarity with this product. So for example, if you are buying the next generation of Microsoft Office, you have some idea what it is because you have used the previous generation of Microsoft Office. So because of such exposure to the product at various places, at a friend's place, at the workplace, or your experience with the previous version, it is likely a fraction of the consumers are able to accurately assess the value of the product even before using the product. So that's basically the motivation. So now let's look at the model. The model is very simple. This is a simplified model. As I said, the paper is slightly more general. So let's just say half of the consumers, this is the true valuation. I'm first talking about the true valuation. This is if everybody knew their true valuation. So half of the consumers would find the product to be a fit if they had full information, and their willingness to pay for the product will be 1 plus delta. And for the remaining half, it will be 1 minus delta. It's like if they know it, then for some people, half of the people, the valuation is $10, and for the rest, it's like $2. So instead of 10, we have written 1 plus delta. Instead of 2, we have written 1 minus delta, if they know. And the marginal cost of the product is obviously 0. So we are taking the same case. Now, as I said, in our model, 1 minus beta fraction of consumers do not know the valuation ex ante. They do not know the valuation. They have to experience the product to know it. For these consumers, their prior valuation is just 1. 1 is basically, why 1? 1 is the average of 1 plus delta and 1 minus delta. Just like 10 and 2, our average was 6. So I'm basically modeling the exact same setup. So their willingness to pay is 1. And for the remaining beta fraction, well, the remaining beta fraction you have to split in two groups, a beta over 2 fraction that knows that this product actually suits them, and their valuation is 1 plus delta for this product. And there is another beta over 2 fraction. This beta over 2, they're both informed consumers. But some people are informed that the product actually is a fit in their case. And the other beta over 2, they know that the product is not good for them, and their valuation is 1 minus delta. So initially, we have 3 groups of consumers: one who know the valuation and like the product, valuation 1 plus delta; one group, 1 minus beta, who do not know about the product, their valuation is 1. And at the bottom, on the right hand side, if you see the diagram, there is another beta over 2 group who know that the product doesn't fit them, and their valuation is 1 minus delta. So this is basically the main model. This is just as simple as that. Now, the next thing is how information actually affects these consumers. So what happens if they get to try a portion of the product, or they get to use a portion of the product, theta. So our full product is of size 1. We normalize the full product to a size of 1. And theta is the fraction of the features. You can think of theta as, in the case of movies, as the trailer, right? If you see a trailer, the size of the trailer compared to the size of the movie is basically theta. And the idea is very simple. We assume a standard signaling model in economics. So if you see a bigger portion of the movie, you get more information. If you see a very small trailer, few seconds, then you get not much information about the product. That's basically the model. So let me explain the expressions in the bullet points below very quickly. These are actually very straightforward examples. Now, what do I mean by a noisy signal? So the idea is, if after experiencing this base version or lower version of quality theta, I start liking the product, what is the chance I will truly like the entire product? That chance, we model it as 1 plus theta over 2. And this is very intuitive. This is the standard noisy signal model. If theta is 0, meaning I have not actually seen any product. Theta 0 means I have not seen any trailer even. I have not seen anything. Then this probability is just half. Half is basically my prior. Half is same as my prior. So basically, I have not received any information. But if theta is 1, basically I have seen the entire movie and I still like it, then 1 plus 1 over 2 is 1. Of course, if I've seen the entire movie and I still like it, then my chance of liking it is just 1. There is no uncertainty anymore about that. So, and if I have seen only a fraction, then I should be somewhere in the middle, and that's why this is 1 plus theta over 2. And all other probabilities are similar. So, for example, if I actually like the product after seeing a fraction theta of it, what is the chance I will not like the product in the end? That is the second bullet point. That is basically 1 minus the previous line, 1 plus theta over 2, which is 1 minus theta over 2. And the same for a negative experience. The fit and non-fit, F for fit and N for non-fit. So this is how basically a consumer revises his probability of liking the product upon experiencing a base version of quality theta. You can think about the base version as like the trailer for a movie. So now, how does this change consumer's valuation? So this valuation revision is a very simple process. So let me explain the 2 lines in the color. So basically, first of all, as written on the top of the slide, for the beta fraction of consumers who already know about the product, this experience has no implications for them. This experience does not change their valuation. They already know it's 1 plus delta or 1 minus delta. So the impact is on the people who are in the middle, whose valuation was 1 to begin with. Now, for these group of consumers, what happens? If they get a fit signal, if after using a portion theta, if they start liking the product, then they place a weight of 1 plus theta over 2, as I explained on the previous slide. They place a weight of 1 plus theta over 2 on liking, which means with a probability of 1 plus theta over 2, their valuation is 1 plus delta. And with a probability of 1 minus theta over 2, their valuation is 1 minus delta. And if you compute the weighted sum, you will end up with 1 plus delta theta. So that's basically what I have on the slide. And then likewise, if you, after using a portion theta, if you did not like the product, then you will place a weight of 1 minus theta over 2 on 1 plus delta, and will place a weight of 1 plus theta over 2 on 1 minus delta, and you'll compute a different weighted sum, and that weighted sum will evaluate to 1 minus delta theta. Again, this is very simple model. This is a very simple model. Think about it. If theta is 0, then you are still at, your valuation is still 1. You are not diverging. You are still at the same point. If theta is basically the amount of information I'm giving you. If theta is 1, then you either end up at 1 plus delta or 1 minus delta. You fully diverge. If theta is somewhere a fraction, then you are no longer at 1, but you are not at 1 plus delta or 1 minus delta either. You have diverged, but you have not fully diverged. So basically, more information means more divergence. Okay, so that's basically what the model is. And as written in the bottom of the slide, that regardless of how they diverge, the average valuation stays the same in our model. The average valuation for the entire group of consumers, informed, uninformed, everybody together, that average valuation in this case is just 1. So this is basically at the heart of the model. We are saying we will work with consistent priors. We will work with consistent priors. We are not going to bake in any inconsistency. That is number one. We will work with zero marginal cost goods, and we will try to see whether the prior research actually holds. The prior research basically says you have to have some sort of inconsistency for this whole math to work. And we are saying, can it work without assuming any inconsistency? So that's basically what we are trying to get at. So I won't take much time. I'll just explain this slide quickly, and then I'll hand over to Professor Dey to sum up the the results. So this is just in case somebody is trying to recreate our results and trying to solve the problem. This is actually a very simple mathematical problem as mentioned here. So the whole idea is the manufacturer has or the software producer has three things to choose. One is the size of theta. You can choose how big your trailer should be, how big your base version should be. So that is the theta that the software manufacturer chooses. And in addition, you choose the two versions, the price for the base version and price for the premium features. The price for the base version is R, and price for the premium features is P minus R. So these are the three choices. So theta, R, and P are the three choices. Now, what is the demand function? When you give for a given theta, given P, given R, what is the demand? Because I have to tell you the demand, only then you can do the price times demand and write the revenue and you optimize. There is no cost in this model because we are dealing with information goods. So we are saying that because the base version is size theta, think about the beta over 2 group that knows that the product does not fit them. Their valuation for the entire product is 1 minus delta. So for a size theta, their valuation is 1 minus delta times theta. And you have to subtract the price of the base version to get the utility of the base version. So for the beta over 2 fraction of consumers who know that the product is not good for them from the very beginning, the informed consumers, for them, the utility is 1 minus delta times theta minus R. Now think about the next group, the group that is uninformed. The group that is uninformed, initially, they value the whole product at 1. So they value a portion theta at just theta. And you have to subtract the price of the base version R to get their utility. Now move on to the next one. For the other beta over 2 informed consumers, they know that the product is good for them. The product fits them. For them, the whole valuation for the whole product is 1 plus delta, which means for a size theta, they want to play 1 plus delta times theta. And again, you have to subtract the price R to get their utility. This is for the base version. For the upgrade, you have the consumers actually split in not 3, but actually four groups. The first group and the last group are similar to what we had before, except that instead of theta, you have to now multiply with 1 minus theta because the size of the premium component of the product is 1 minus theta, and the price is P minus R. So for the group on the top and the group on the bottom, they're same as whatever we had for the base version. But let's think about now the group in the middle, the 1 minus beta fraction of consumers who were initially uninformed, but now they are somewhat informed because they have used a portion theta of the product. Those who got a negative signal about the product, basically they found that they really don't like this product after using a portion of it. For them, the valuation for the whole product is 1 minus delta theta. So for a size 1 minus theta of the premium size, they want to pay 1 minus delta theta times 1 minus theta. and then you subtract the price of it, you get their utility. And the same is for the 1 minus delta beta over 2 portion of consumers who now, after using the portion theta, starts liking the product. For them, the valuation will be 1 plus delta theta times 1 minus theta minus the price, which is P minus R. So this is basically your entire demand curve. Based on this demand curve, you have to choose theta, P, and R. And the question is, when you optimize, what result you get? And I'll let Deb explain the result what you gave when you after you optimize with respect to PR and theta. Muted. You are muted. You are muted.
Thank you, Atanu, and thank you everybody for attending the talk today. So let me go over the results. Quickly look at the analysis a little differently. So first we'll look at what happens when you offer just one version. That means there is no theta, the entire product is offered. In that case, the manufacturer can charge either 1 plus delta as the price for the entire product, and then this beta by 2 fraction will buy that, right? So that's the demand, so that's the profit. Similarly, if the manufacturer charges a price of 1, then you are going to get this group as well as this group, so the total profit is going to be that. And if the manufacturer charges 1 minus delta, essentially everybody will buy the product, and as a result your profit is going to be this one. And so for a given set of parameter values, the manufacturer would choose the best option among the 3, and that will be our benchmark. That will be the 1 version case. Now you look at the 2 version case. Here you have theta and 1, as Atanu mentioned earlier, and these are some of the choices. He already talked about these choices. And when you look at all these choices, you can show that several of them are actually suboptimal. Upfront, you can eliminate them from your analysis, which will leave you with only 2 cases, right? This is case 1, where R is theta, and P minus R is 1 plus delta theta times 1 minus theta. And the other one is R is 1 minus delta times theta, and P minus R is 1 plus delta theta times 1 minus theta. And we actually call them case A and case B. Okay, so now let's look at what the result would be. And here again, the manufacturer chooses the best option given the parameter values. So now we already talked about the case of beta equal to 0 and beta equal to 1, and we said that versioning is not optimal in these 2 extremes. So now let's look at what happens in the middle. Well, it turns out that versioning can indeed become optimal in the middle, right? So for example, you can see that versioning is optimal here, and that will happen through case A, and versioning is optimal here, which happens through case B. So in other words, our results are actually consistent with prior literature. So at the extreme, we do get no versioning, right? But in between, we actually find that there is versioning possible. Now, these 4 regions, the 2 no versioning regions and the 2 versioning regions, are interesting. So let me describe them a little bit. So if you look at the no versioning region at the bottom, that is the case where information dissemination itself is suboptimal. Forget about versioning. Even if giving information was costless, even then the manufacturer would not give information. And that is because of the things that Atanu explained earlier. Basically, you can do much better without giving the information. You are basically doing first degree price discrimination. Beyond this line, giving information is optimal. So in this entire region, giving information is optimal if that was costless. If giving information is costless, then you would give information. But what happens in case of versioning is that giving out the information is not costless. And that is because when you give information in the form of a lower version, you are actually cannibalizing some of the demand for the higher version. And that cannibalization cost basically makes it suboptimal to give a lower version or a base version here. But in this entire region that is shown in green, actually giving information through the version is actually optimal. Okay, so that's basically what we find. And as I said, at the extreme, you can see it's no versioning. The entire thing is no versioning. And at this extreme, you can see it's no versioning again, all the way, no versioning. But in the middle, giving a version is actually optimal. So what have we learned from this exercise? First of all, we find that versioning can indeed be viewed as a special case of information dissemination, because by providing a lower version, it acts as a product sample, and consumers can get some information about whether there is a fit between their desire and what the product offers, right? And in this case, you can think about cannibalization loss as the cost for information dissemination. So in the marketing literature, they talk about the cost of information dissemination. So for example, if you invest in advertising, or if you do a particular expo or a game show, there are costs associated with that. But in our case, that cost is not there, but the cost comes in terms of cannibalization. The second insight we find is that the no versioning result is very brittle. So the no versioning result, which has existed for such a long time, more than 3 decades, which basically says that if the priors are consistent, that means the willingness to pay is the same before and after getting the information, then there is no point giving information, so there is no point versioning. That result is actually quite brittle. It only works at the two extremes of beta equal to 0 and beta equals to 1, but for all other values in between, this result actually breaks down. In other words, there is actually a region for every value of beta. There is some region, any value of beta you think of, there is some region where giving information is actually optimal, or versioning is actually optimal. The next thing we find is that the usefulness of version 2 upgrade has been understated. So in the prior literature basically says that providing a version or version 2 upgrade is useful only when there is an upward swing in the WTP. That means the posterior WTP becomes larger than the prior WTP. That means the consumers underestimate the product. We show that such a condition is not necessary. Even when the WTPs are consistent, the priors are consistent, the prior and the posterior are the same, even then we find that version 2 upgrade can actually be a useful strategy for the manufacturer. And finally, this is also very interesting. If you look at the vertical differentiation literature in economics or in marketing, you'll find that vertical differentiation is always accompanied by an expansion of the market. By providing a lower quality, you attract more people to come to the marketplace, right? What we find that vertical differentiation is actually possible without any expansion of the market. In fact, in the versioning region A, there is no market expansion per se. There are no more consumers buying it. Same number of consumers buying it, but they are willing to pay extra for that 1 minus theta fraction. So that's what makes it optimal. So these are the 4 main insights that we find from this exercise. So I think that's all we had to say, unless Atanu wants to add something. If not, then we are ready for questions and comments.
Thank you, Dr. Dey and Dr. Lahiri, for this insightful and productive session. So we are now open for questions. I would request everyone to write questions in the chat box or the Q&A box.
Hello, Dr. Dey and Dr. Lahiri. Thanks for a very insightful presentation. This is Chitra Kalpan. I have one question. You have just explained that how information dissemination it is really helpful, and using versioning, the consumers get more information. So after buying a smaller and demo version, they can probably upgrade to a better version. So I'm just wondering, like, is it ever possible that after using the version 1, they might not want to upgrade, where otherwise they probably would have gone for the full version? That can it backfire having a lower version? Is it possible? So consumers, they just don't like the first experience. Now, the reason why I'm asking is that it has a couple of years back, there has been a lot of cases where a certain video game company, so their consumers completely rejected their games. So, and they had to withdraw their games, they had to redesign, and they had to market it once again. So is that a possibility, that having a lower version, might it backfire?
Yeah, certainly. That's precisely what we are saying, that when you give the information, when you give the lower version, some people might not like it, and these people are not going to buy the upgrade part of it. And if you did not give that information, if you did not give the product sample, these people would have thought that the product is actually a fit without, because they don't have the information, and they would have purchased the product. So some people would just stop at the lower version of the product, and that's precisely what actually adds to the cannibalization loss that we have been talking about, that some people are just going to stay put with the lower version and will never find the urge to upgrade to the upper version, higher version.
Yeah, so in our case, just to clarify, initially people are at 6. Remember the numerical example from recall that numerical example. And then after getting information, some people will be at 10 and some people will be at 2. The average is still 6. But it is possible that some people actually say, after knowing about the product, some people say, no, it's just worth 2. It's not worth 6. I had a prior of 6, but now that I know about the product, it's just 2 to me.
Yeah,
but in our case, what does not happen is that not everybody will say 2. That's not possible, because we assume consistent priors. So you assume that the average remains the same. Because if you play with the average, it's very easy to get results. Of course, if the average goes up, then of course giving information is a good thing. Average goes down, giving information is a bad thing. There is nothing surprising. So basically what we are saying, the prior research, whatever they looked at, is not very interesting or surprising. But what happens if nothing changes on average? It's just that people diverging. It's just some people like the movie. One guy says, wow, what a great movie. Other guy says, boring, too much action, random fighting. I don't like all this fighting. The other guy says, I like all the action. So that's the kind of situation we are modeling. Some people will not like the game. Some people will like the game. On average, it will stay at 6. So yes, so we do account for the case that some people will not like it after knowing about the product. But in our case, it cannot happen that nobody likes it after knowing about the product, because then the priors will not be consistent with the posteriors. We are working with consistent priors, and we are showing that even when we work with consistent priors, we can get some very interesting results. And we do not need to, artificially bake in inconsistent priors to get any interesting results. That's basically the main point of the paper.
So we are getting some questions in the Q&A room.
Oh, okay.
Anjuman, are you going to read those questions out, or? Yes,
I will
please.
read out the questions for you. So the question is by Arushi Jain. She says, in the digitalized world, information gathering is not difficult. So if we are not disclosing some of the information and consumer is getting it from somewhere else, would not it result in more loss, as the information from informal sources can be fake or distorted?
Okay. Can I take that question, Atanu?
Yeah. Yeah, go ahead.
All right. So there are two things going on here. First of all, the information that the consumer is getting, that's coming, we are only considering the information that's coming directly from the manufacturer, either in the form of a product sample, or in the form of advertisement, or in the form of an expo or a game show where consumers can come and experience the product. So the question of fake or distorted does not arise in our case, right? So one can obviously argue that, if manufacturer one is, sending some information, there may be some other rival who can come and do disinformation and all that. Those are not our concerns, because in our case, the manufacturer is a monopolist and there is no competition. Of course, when there is competition, things will change a little bit. So that's the first part. Then the second part is that you are talking about information gathering. Well, let me once again, I think Atanu said this earlier, but let me once again make the distinction between a search good and an information or an experience good. In case of search good, you can get information from others. You can get vicarious experience about the product, and you can take that informing your opinion. But as far as the experience part of it, vicarious experience will not work. Only personal experience will work. So, in other words, I may rely heavily on Atanu's opinion, and he might tell me that such and such movie is good, and I might actually take his recommendation and go and see the movie. But at the end of the movie, I might still not like it. And that's because my personal experience is going to be very different from his personal experience. And we are talking about that part of the product, the experience part of the product. Now, in reality, of course, every product is a combination of some search component and some experience component. Atanu talked about the detergent. The aroma of it is experience component. The quality of how well it cleans my clothes is the search aspect of it, right? So in reality, all products are a combination of the two. But of course, in an abstraction, in the modeling world, we are not talking about the search part, because we only want to focus on the experience part of it, and that's how the paper has been written.
Thank you, Professor. So there is one more part to this question. Does the elasticity of product affects the amount of information that should be disclosed?
Yeah, I can answer that. Actually, that is actually correct. I mean, the answer is yes. Anshi, Anshi,
Arushi,
Anshi actually, okay, I'm not wearing my glasses, so Arushi, I, okay, Arushi. So Arushi is actually right. Yeah, it does matter, because when you optimize, as they was walking you through the solution. I don't know. I mean, we did not write all the algebraic expressions on the slide, but the theta, the optimal theta, theta star, you can call it theta star or the optimal theta. When you optimize theta, the optimal theta is indeed a function of delta. So the optimal theta is indeed a function of delta. The delta basically represents the elasticity. So basically, the larger the delta, the more will be the demand will become more elastic in our model. But the optimal theta, the value of theta star, is indeed a function of delta. So how much information you disclose will actually depend on the elasticity. So the main idea is that why does this work in our paper? I'll just come back to that using this question. It works because originally, if you have everybody informed, if everybody is informed, then basically because of every version has zero marginal cost, because of the marginal cost issue or cannibalization, however you frame it, versioning is suboptimal. When everybody is uninformed, the main thing works against us is that
I think Atanu's connection, your connection got destabilized, I guess, became unstable for some time, and we could not hear you. Can you hear us,
so
Atanu?
yeah. So let me just, I can hear you.
Yeah, so for a few seconds you just froze. Your
So
dial
let me just quickly go over what I was saying. I was saying that The main idea is that when all consumers are uninformed, we don't want to give them information because they become more heterogeneous. They become more heterogeneous, and that works against us. But when not all consumers are uninformed, regardless of the elasticity, regardless of delta, we want to give them some information. So basically, beta is not zero. Beta is a 0.1, 0.2, 0.3, whatever beta we have. There is a band of delta. There is a band of delta for which giving information is actually optimal. And this is because when some consumers have information, basically beta is strictly between 0 and 1, the connection between keeping consumers in dark and first degree discrimination gets broken. And that's when the information dissemination becomes optimal. But as clear from the picture that they've showed, that indeed delta determines that how much information should be given. If delta is small, then you don't want to give any information. And as delta becomes larger, you want to give them information. So as you can see, at lower delta, we are in the lower no versioning region. And as you increase delta, we end up in, say, no in versioning in case A. So delta, determines the amount of information that should be given. And also the theta star, optimal theta star is also a function of delta. So yes, the question is correct. And, the answer is yes, that it does depend.
Thank you, Professor, for the answer. I guess Arushi has got her answer clearly. And thank you for the analogies that you've used to simplify the concept, the movie analogies for explaining the theta, the relevance of theta. So I would like to ask one question here. So you were explaining the cannibalization loss, and while you were comparing with the marketing or exposed cost with the cannibalization loss. So while when the company plans for the marketing for expo, so they keep a cost to profit kind of ratio. So if we are investing this amount, how much profit are we going to get with this particular advertising or particular promotion? So as per your concept in the cannibalization loss, so any such considerations are there while deciding these losses?
So I'll just quickly tell you that advertisement is actually a very vast topic. So first of all, sometimes you give, as we were talking, that a good can have search and experience components. So when we are talking about search components, giving information actually reduces demand elasticity. That actually works in the favor of the manufacturer. So that is one effect of advertisements. That if you give them information for a search good, right? For example, if you tell that your computer is really fast, then people will, will know, okay, it has a very high quality Intel CPU. They want to pay more for the product. So there is no experience part in those products, and advertising has a very different role there. Then advertisements can be used for signaling. So for example, only, in the middle of a World Cup, final match, soccer final match, only I can advertise. That means I am very powerful. You can actually use advertisements for signaling. We are not talking about any of those advertisements. We are basically talking about advertisements that gives people information about their subjective part. So it's more like you can come to the game show and you can actually try the game and gather information yourself, that kind of information. So the cost of giving that kind of information is here similar to the cost of cannibalization, the cannibalization loss. So we are only talking about advertisement to give information on the experience part of the product. So that's basically all we are talking about. The other types of advertisements are not in the model, and they would complicate, all the analysis.
Okay.
So that's what I would say.
Thank you for clarifying, Professor.
And I'll just add that, this cannibalization loss is there in the green regions as well. It's not like there is no cannibalization loss there. Simply that the cannibalization loss is lower than the extra profit you can make through product sampling. And it's only in this pink region that the cannibalization loss overshadows your extra profit, and that's why you don't want to give out information there.
Thank you, Professor. Any other questions that you would like to ask? Panelists or the audience?
Yeah, while people ask, I will just mention another thing. This picture is unfortunately not in the paper, because this picture is, I think, is better pictured than the ones in the paper. The reason is nothing. The reason is the paper was done, it got accepted, it got published. We did whatever the referees wanted us to do, and blah blah blah. So that is a part of the thing. But after the paper was published, we were still thinking of ways, and in fact, Dave was thinking of ways to make them to convey the message to a broader group of people. For example, presentations like this. And so Dave later on came up with this diagram, and I think this diagram is much more informative than the diagrams in the paper. So I think that's one point I would like to make. It's the same diagram, but presented in a slightly different way. But this is definitely more, more intuitive, and it's much easier to relate to.
Thank you. So, any more questions? I guess there are no more questions. If you have any question, either you can write the question in the chat box or the Q&A section. We'll wait for maybe 2-3 minutes if someone asks the questions.
Yeah, sure.
And then maybe we can end the sessions. So, Professor Lahiri and Professor Dey, thank you for joining with us today and sharing this interesting concept about versioning.
There is one question, I think.
So there is one question. Yes, please. So there is a question from Anushriya. She says, for instance, a company keeps introducing different versions of their product, and the amount of information they release for each product differs. Doesn't it affect the consumer's knowledge?
I'm not entirely sure about the question, but by version we do not mean Windows 8 versus Windows 10. We do not mean that that's a version. By version we mean Windows Home Premium versus Windows Enterprise. So we are talking about the same release of the product, but different versions within the same release of the product.
She's saying, I mean, consumer's preference. Does it affect the consumer preference? So, but then there are different.
Yeah, I mean, it's depending on whatever information company releases, there will be a prior. So people will say it's a $6 on average based on whatever I read about the product online. There are some experts reviews. I also read the experts reviews. I go into some consumer forum, Stack Exchange or whatever, Quora. I asked 5 questions to some expert in Quora. I got some answers, but all of that is actually, subsumed by, our $6, so that is in the $6. So after reading all the things I can get from other people, and including whatever the manufacturer has released, I come to the conclusion that on average, it's like something worth $6. But then there is still some uncertainties. For example, I know Amitabh Bachchan is in the movie. So I know, okay, I want to pay so much money for such a movie because Amitabh Bachchan is in the movie. So I want to at least pay, I am fine paying, $500 for a movie ticket because Amitabh Bachchan is in the movie. But that does not, but after watching the movie, some of us actually can like the movie a lot. Oh, wow, that was the best movie by Amitabh Bachchan ever. I would have even paid $1,000, for this movie. Some people will say, Amitabh Bachchan was there, but it was so overall the movie is not bad. The plot was so boring and the movie was so slow. And so they would be willing to pay less. So some people say, I wouldn't have paid anything for this product. So it's possible. So based on Amitabh Bachchan is in the movie, that's an information. But based on that, you have a prior. But even then, after you watch the movie, you will diverge. So that's basically the main idea, that there is a subjective component of the experience. The same movie, one consumer likes, the other consumer doesn't like. And we are basically, looking at that information, that basically what makes people diverge. We are not looking at information that makes people move that can make consumers move in the same direction. We are not looking at that. So for example, if you say the movie is not in 2D, it's in 3D, then everybody will be willing to pay more for the movie. 3D is better experience than 2D. We are not talking about that. We are talking about subjective part of the information, which upon getting, some people will say, wow, great movie. Some people will say, No, how can you say this is a great movie? It was not a great movie. So we are talking about that kind of information that makes us diverge. And what we show in when people diverge, it is not necessary that they have to move upward on average for such a strategy, such a versioning to upgrade strategy to be optimal. Even if the whole group of consumers don't move on average in either direction, positive or negative direction, on average their valuation stays the same. What is happening is they are just diverging, they are just disagreeing with one another, but on average they are still at the same point. Even then versioning to upgrade can be optimal. That's basically the main point of the paper.
Another way of thinking about it is think about all the search component of the product that you can get information from outside. All of that is embedded in that one. So then 1 plus delta and 1 minus delta, that is just the fit part of it, the experience part of it. And it doesn't have to be one. Actually, if the product is really, really good, and searching about the product, you come to know that it has all these things, all these features. It can be greater than one also, but you can normalize it to one. So suppose it was 2. So 2 plus delta and 2 minus delta, that you can substitute by 1 plus delta by 2 and 1 minus delta by 2, and then use a different delta, which is delta by 2. So you can normalize that within the scope of a positive model. You can normalize that. So that's how we completely take the search component out of the equation and focus solely on the experience part of it.
Thank you, Professor Dey. Thank you, Professor Lahiri. Any other questions do you have? Please write in the chat box.
There's another question from
Yes.
Anushya.
Yes, so she explained the question, I guess. For example, a company produces 2 versions of a soft drink. For product A, we are releasing 10 ingredients, and for product B, we are releasing the names of only 7 ingredients. A consumer may, at the end of the day, prefer to consume product A because we are more aware of what he is consuming, so it's affecting the sales of their own product B.
The ingredient is the search part of it. But after putting the ingredients together, right, the taste could be very different. And if you don't believe me, you can ask my wife. We can use the same ingredient to cook the same dish. Her cooking is much better than mine. So ultimately, we are talking about that taste part of it, that experience part of it. It doesn't matter that the curry had cumin and onion and all the things. Those things don't matter. That part of it is already embedded in that one that we had in terms of the thing. We are talking about the delta. That's the taste.
Yeah, and also we're talking about the taste, and also the taste is subjective. Even if you put the same ingredients and the same drink, you drink and I drink, you will say, wow, this is amazing, the best drink you have ever had. I'll say, what is this? Why they put so many things? It's so confusing that nothing clear, no flavor clearly comes out. They just ruined it. So there is a subjective component. We are only talking about the subjective component in the paper, where consumers disagree after experiencing. They diverge after experiencing.
Exactly.
So it depends on the cook plus the taste buds of the person.
Yeah, there's no taste buds. It's truly taste buds of the person. Of the person is the keyword. It's subjective. We're only talking about subjective information, giving subjective information. We are not talking about giving objective information. Objective information is a separate issue. We are only talking about the consequence of giving subjective information, because subjective information is what makes people diverge. That what basically is risky, because if you make people diverge, your demand curve becomes elastic, pricing becomes difficult. And we are showing, but even such a bad thing you want to do actually. So that's basically the point of the paper. But objective information actually make people come together, right? So objective information can be your degree, right? When you show that you got a degree from your university, everybody says you are a better student. Nobody thinks that, by the degree makes you a worse student. Well, a person with a degree and a person without a degree, everybody prefers the person with the degree. So there is no confusion there. That is the objective information. So if you show people that you have a degree, you tell them that you have a degree, that's also information. That's like an objective information. But we are not talking about objective information. We're talking about subjective information here. So ingredients are fine, but the idea is that even after 10 ingredients, it's not clear all consumers will have the same opinion about the drink. Some people will say, oh, wow, the combination is great. Some people will say ingredients are fine, but the combination kind of, they kill each other's flavor and it's not, very good. So that's the subjective part we are talking about in the paper. And we are showing subjective, we're saying that giving subjective information can be optimal, even in situations where prior research says, giving that is not optimal. That's basically the main thing. Yeah, go ahead.
Yeah. Another interesting part of this work is that it shows that even when consumers are horizontally separated or segmented, you can actually place the product vertically in the product space. So let me elaborate on that. So consumers are horizontally separated in our case because it's completely based on taste. It's not based on the objective information about the product. But in the end, the manufacturer, since the manufacturer cannot place the product in a horizontal dimension, the manufacturer actually is able to place the product vertically. That means it gives a higher version of the product. Everybody agrees that the higher version is better than the lower version. Irrespective of the fit aspect of it, everybody knows that the higher version has more features than the lower version. But the manufacturer, the product sampling literature is like that whenever consumers are horizontally separated and you want to give them the experience, you give them the experience with the lower version, which happens to be differentiation along the vertical dimension.
Yeah, that's a great point, actually. I like that.
Go vertical in a horizontal market, basically.
Yeah.
Thank you, Dr. Dey. So any other last question for the session? With your permission, can we end the session if there is no further
Yeah,
question?
I want to thank everybody, at OP Jindal School, OP Jindal University rather, and Chitrakalpo and all his colleagues, Anjuman, you. This was an excellent opportunity to connect back to India and some, people in India working on economics, management, and other areas. And this is actually a rare opportunity, and I'm really grateful for the opportunity.
Same here. Really enjoyed giving this talk, and thanks to all the organizers, in particular Chitrakalpa and Yuman Yu, for this opportunity to come and present our work.
Thank you, Dr. Lahiri. Thank you, Dr. Dey, for this session. And we hope to host you in person on our campus when the situation returns to normalcy.
That would be great.
Thank you. On behalf of Jindal Global Business School and Center for Research in Emerging Economies, thank you for joining us today. And I hope to see you again in the next Inspiration Lecture Series. Thank you, Dr. Dey. Thank you, Professor Lahiri.
Yeah, thanks.
Thank you.
I'll end the session now.